Okay, we're to the point now where I feel like I can dive in just a little bit deeper into one of these concepts, and that is flash duration. Up until this point, we've used kind of a very oversimplified explanation of the speed in which a flash fires. Using my LumiPro LP180, I basically said when I fire this, let's assume that it fires at 1/10,000th of a second. It's almost instantaneous, for the purpose of just understanding how flash works. In reality, it doesn't actually kind of work that way. When we see this light, when we see this flash, we see it as being either on or off. It's either flashing and it's firing instantaneously, or it's off. In reality, if we were to slow it down, it doesn't quite work that way. Let me show you what a flash output graph looks like. If we look at this graph, ignore the numbers for right now. If we look at this graph, you'll see that it starts at 0% right here. It goes up to 100%. Now that 100% is basically where the flash fires, where that output happens. So what's happening is the flash is charging up at 100%, it outputs the power that you've set here, whatever that power might be. And then it trails off. Now, when we watch this, when we look at it, it looks like that trail is instantaneous, like it just drops right off, but it actually doesn't. The light, when it fires, it slowly actually dissipates. Flash duration is measured by 2 times, and really one of them is the most important. They're called the T5 and the T1 times, or T.5, T.1. What that essentially means is a T.5 time is the amount of time it takes for 50% of the flash power to dissipate. That time is actually the time that most manufacturers use when they tell you what the flash duration is. There's a problem with that. If only 50% of the power has dissipated, what about the other 50%? Well, the other 50% is still going to affect your image. So if the flash duration is slow, that 50% is going to actually affect something. So what's more adequate, what's a better measurement of the ability of a flash to freeze or to know what the flash duration is the T.1, the T1 time. The T.1 time is the time for 90% of the light to dissipate. And that remaining 10% that trails off, it's really not going to affect much, okay? That's what really matters. Now in this graph, I labeled this is the world's slowest flash. Okay, there's no flash that's actually this slow. This is in milliseconds at the bottom. So 0, 200, 400, at 1,000 milliseconds, we're talking about 1 full second. So the T5 time for this sample flash is at 1/500th of a second, or 1/2 second is the T5 time. At 1 full second is the T.1 time. Meaning that if you actually own this flash, it would basically be equivalent to turning on the light bulb and turning it off. That's how slow it would be, okay? There's no flash that exists that's that slow. This flash would have no ability to freeze a subject in motion because it's a terrible flash. It doesn't exist, but it does help to illustrate the point. In reality, every flash is actually different, okay? So depending on the brand, the make, the model, the flash duration is gonna differ. There's another interesting thing. The T.1 time is the best measurement of the flash's ability to freeze a subject, but the higher the power that you use, that's point number 3, the higher the power, the slower the flash duration. So the slower that T.1 time. The lower the power setting on your flash, the faster the T1 time. So the faster the flash duration. A pocket strobe is generally going to be faster than a studio strobe, generally, okay? So that's why oftentimes when people are working with liquids, when people are working with like kind of close-up macro, dropping things into things of water, they're using pocket strobes because they're convenient, they're easy to manipulate and so forth, and their flash durations are very quick. So to freeze water, you need a very, very quick flash duration, 1/5000th of a second, 1/10,000th of a second to freeze water. And sometimes studio strobes can't quite get there. So if you want to get T1 times for a specific flash, you can look online. A great resource is actually from Andy Gok. Andy Gok at gok.net. Andy's done some fantastic testing on flash durations. Oftentimes you can find the T1 time from the manufacturer themselves, but sometimes it's not available. So just look online, you can find the actual flash duration. I would highly recommend doing that before purchasing new flashes because you might end up with flashes that might not have a fast enough flash duration for whatever use you might have. For most people, this generally is not an issue. But if you're wanting to use your flashes to freeze motion, this becomes a problem. So let me go over some sample times. At 1/1 power, so at full power, a Canon 580EX, which we use in this tutorial series, has a flash duration of 1/250th of a second, meaning to get 90% dissipation from that light, it takes 1/250th of a second to get there. that means that it might not flash, it might not freeze to the effect that we talked about earlier, right? If we talked about this being 1/10,000th of a second, 1/250th of a second is kind of slow. So you're gonna get motion. So if you flash expecting it to freeze and you see motion in there and you're like, wait, there was no ambient light and my shutter speed was super high and I'm still getting motion, it's because your power might be too high or the flash duration, regardless of the power, is too slow. But look at this. On a 580EX, if we slow down to 1/2 power, immediately our flash duration goes to 1/919th of a second, okay? So almost 1/1000th of a second. At 1/64th power, so very low power setting, we're at 1/14,000th of a second. That's why I told you just to assume that this was 1/10,000th of a second, because we're at like 1/16th or 1/32nd power right now. On a Nikon SB80, 1/1 is 1/258th of a second. 1/2 is 1/1100th of a second. And 1/64th is almost 1/16,000th of a second. On the Einstein, let me just grab the Einstein so he's not just hidden down here. Let me grab this guy. All right, so here we have our Einstein full studio strobe. Now this guy, at full power, 1/1 power, this is putting out probably, I don't know, 5, 6, 7 times the amount of light of one of these pocket strobes. It's actually still pretty decent. At that much power, getting that much power is still faster. It's at 1/400th of a second, as opposed to a pocket strobe, which is around 1/250th of a second. So for full power and for the amount of light it puts out, it's really quick. But you'll notice that they don't get as quick. This is actually a very fast studio strobe when we're talking about flash duration compared to other studio strobes. Look at this. At 1/2 power, it goes to 1/1000th of a second, but at 1/64th power, it only gets down to about 1/3700th of a second, which is still very fast. It's still fast enough to freeze liquid, which is why this is often used for liquids and gases and those types of freezing applications. But it doesn't compare to 1/14,000th of a second or 1/16,000th of a second of that of a pocket strobe. So a pocket strobe is still gonna be quicker. Now, remember what I talked about with brand and flash quality and so forth? Not only can it affect things like color and power output and so forth, it also affects your flash duration. A crappy generic eBay light, okay? At 1/1 power, it's 1/140th of a second. At 1/2 power, it's 1/126th of a second. It's actually getting slower. At 1/32nd power, it's at 1/100th of a second. A flash like that has absolutely no ability to freeze. The fall off is too slow, and as you know, the light's falling off, it's gonna affect and create motion in a shot. So quality of your strobes is actually a big deal. Look for reviews. You guys can take recommendations from us. We use great stuff in this tutorial series, but always when you're looking to other stuff, look for reviews before you go out and buy something because it might not fit the use that you might need it for. All right, so hopefully that makes sense. Hopefully you understand flash duration. The speed in which that really matters is that T1 time, okay? For 90% dissipation, that's how you know basically how good a flash is gonna be at freezing motion.